This is the model answer for the pie warmer task, task 7. So start off with your design. Remember, you need to go through the TTRC, so tool, trial, results, calculations. So if we start off, so I'm going to generate the random numbers 1 to 100 on my calculator using the random int function. So that's obviously the tool part. The numbers will represent the customer's choice from the pie warmer. So this is starting trial. You then got to allocate which numbers represent which ones. So it was 20% for the toasty, so you end up with 1 to 20, and then 21 to 70 to represent the customer order as a pie, and 71 to 100. Now, generally, most of the time, this is where the errors are made, is that a common mistake is to not remember to move the number along one. So for the pie, they'll write 20 rather than 21. And of course that changes the probability, so you need to be really careful about that. The other thing is that the probabilities might not be really nice numbers, so you as in divisible by 10, so it might be that it's 33%, so you need to make sure the numbers all add up and that each number represents a different thing. Okay, and then the other thing to include is the number of times you're going to repeat it. So for the trial, you're doing it 10 times to represent 10 customers, and all of that is one trial. Okay, now because it's divisible by 10, you can reduce it down to 1 to 10, and obviously the numbers can then be reduced down as well. To keep it safe, I would always make sure that you keep it 1 to 100, therefore you can work with any percentage. Other than that, it's all the same. So the next part is the result. So the thing we're looking for is whether everyone gets what they want in the morning. This will mean the customers will order 3 or less toasties, 6 or less, or 4 or less sausage rolls. Otherwise, the result will be a failure. Okay, and then the next part is then to also include the number of times you're going to repeat the trial. So in this case, it's 20. For the exam, you should aim to do 15, but if you only do 10, that's okay. 9 or less won't be enough, so you need to make sure you allocate yourself enough time. If everyone gets what they want for all 20 mornings, then the shopkeeper's claim is correct. So you go back to the task and you can see whether what they're claiming to see what you're looking for. Right, next stage is to set up your table and also define the calculation that you're looking like. So I'm going to look for the probability of success. That's the number of times I get a tick in this column out of 20. So that's the C in the design. All right, if your design's not right, it's not achieved. So you have the table here. So what we're going to do is just simply record 10 numbers, and then we're going to see how many toasties we ended up with, how many pies, how many sausage rolls for our 10 customers each morning. So this is after running the task. You can see there were 4 times we ended up with no, someone didn't get what they want, and we can see why is that toasties both of these times. Here we ended up with 5 sausage rolls, and the last one we ended up with 4 toasties again. So that bit's really important for the extension work, is thinking about, well, of the times that people missed out, they were short on toasties. So it might be that we need to increase the number of toasties we put in the pie warmer. So the conclusion, we know it's 16 out of 20. So the shopkeeper's claim is incorrect, as not every morning customers got what they wanted. So that's the achieved part sorted. We've gone TTRC for the design, and we've answered the claim from a simulation we've run, and it's been done more than 9 times. So then moving on to merit, we need to start talking about that the assessment is just the simulation is just a estimate of 20 trials, or however many trials you do. That if you actually increase it, it might be that if we increased it, we would get closer, a higher or a lower probability. But obviously we're not going to get 100% because people have missed out already. The key things you need to do is talk about that. Talk about that it's an estimate, okay, and that we can, if we increase the number of trials, we also we could come to a different conclusion or a more accurate answer, something that's close to the theoretical probability. This simulation assumes, so talking about our assumptions now, this simulation assumes that every customer will order something from the pie warmer and that this choice is independent of other customers. In reality, this would not be the case. I would expect the probability that a customer is disappointed is lower, as many people would be happy with a sausage roll instead of a pie. So even though they would go to something, they could substitute it quite easily. That's the difference between the simulation and the real world, and that's really what the assumption is about. The last one is, one suggestion I could make to the shopkeeper would be to increase the number of toasties. If you remember back to my results, increase it to 5 toasties. Now that would have meant that our success rate would have gone from 16 to 19, as this would make his claim correct. All right. So that last one is a suggestion that if you take a look at this, you can see that there were our 3 situations here would have been okay by increasing it up to 5 toasties rather than 3. So that would do it. You could extend that to say that you could increase the number of sausage rolls as well, then we would have got 100%. So basically that's all of it. Key thing is to make sure you follow the marking schedule and that you know what each one of the points means.